You're listening to Switched On Australia, the podcast that tracks the opportunities and challenges of electrifying everything, everywhere. Switched On is brought to you by the publishers of Renew Economy, Australia's best informed, most read website focusing on the green energy transition, and is supported by Boundless Earth, using philanthropy, investment and direct advocacy to help Australia become a global force in a decarbonised world. Hello and welcome to another Switched On podcast. I'm Anne Delaney. Thanks for joining me. And I'd like to acknowledge that Switched On is recorded and produced on Arakwal country, part of the Bundjalung Nation in northern New South Wales. The market for lithium-ion batteries is rapidly growing in Australia and globally as the demand for electric vehicles and battery energy storage systems increases. But as the demand for batteries increases, so does the need to work out what we do with all the lithium-ion batteries at the end of their lives. Australia currently produces just over 3,000 tonnes of lithium-ion battery waste each year, but that figure is growing by about 20% every year. Lithium-ion batteries contain valuable resources: lithium, cobalt, nickel, manganese, copper and other critical minerals. So obviously, old batteries aren't really waste at all. About 95% of these valuable components can be recovered with the technologies we currently have. And recycling batteries will also reduce the need for new mining and extraction, which will be critical for getting to net zero. But currently, Australia's capacity for recycling lithium-ion batteries on a commercial scale is limited. Gavin Collis is a synthetic chemist working in the battery space at the CSIRO in Melbourne, and he's my guest on the podcast today. I started my discussion with Gavin by asking him what distinguishes a lithium-ion battery.
There's two types of batteries. There's a primary battery and then there's a secondary battery. So most people are familiar with primary batteries. They're the things you have in your electronic devices, your toys that you get at Christmas. You use them, and once they're used, you throw them away. So what's really good about a lithium-ion battery is it's a secondary battery. So when it uses up all its charge, you can actually recharge it and keep using it again and again and again.
Well, we still don't know, though, how long some of these big batteries that we're going to need as we move into an electrified future is going to be. Is that a problem when it comes to anticipating what we're going to do about the future of lithium-ion batteries?
I think, look, that's a really good question. Being quite new to the field, I've been fascinated to see how the whole lithium-ion battery technology has transformed over the years, and it's transforming very fast. So what we've seen is lithium-ion batteries were typically used for your portable electronics, your laptop, power drills and things like that. And then along came the technology. It was shifted into electric vehicles, and that's seen a massive uptake. And we're also seeing it now move into the battery energy storage system as well. So one of the things that is coming to light now is the enormous demand of materials that go into making batteries, but also the lifetime. How long will these batteries last? And so one of the real questions there, it really comes down to how the battery is used in that end use application. So that's still work in progress, I guess. We're still using some of this technology to see how long it goes. But at the same time, there are people looking at seeing if they can improve that lifetime and make the batteries last longer.
So, Gavin, have you been surprised by the pace at which the energy transition is happening and how that is going to impact on the recycling industry, for instance?
Yeah, that's a really good question. I think when I first started doing batteries around the 2017, it was happening, but since then it's really accelerated much faster than what people have even suggested. I think people have thought about, when raw materials might drop off and you'd start using recycled materials, but I've seen, that sort of 20-year window really contract down to even to the 5-year window. It's just happening so fast. And I think people realise in countries, if you can get there and have those industries that can supply batteries that are going to be ubiquitous in everything that we have, from electric vehicles, home storage, grid storage. I mean, that's a huge market to be involved in, to make your country very wealthy, I guess, and be sustainable domestically and internationally. So I think that's what's really causing this acceleration that we're seeing. It's going to be the future of where we go. Energy storage is quite important.
It does raise the issue, though, obviously, about battery recycling. How important is battery recycling going to be?
Like I said, I think it's quite interesting. In a very short period of time, since around 2018, I was fortunate enough to be invited to the Department of Energy, which had its inaugural workshop in Colorado, one of the national labs. That's a National Renewable Energy Laboratory in Colorado. And so they were thinking about it back then, about this massive uptake of lithium-ion batteries and what would you do at end of life. So recycling is a really important part. And part of that reason is because of net zero. When we take raw materials, we use a lot of energy to process that material. We generate a lot of waste as well. But if you take something that's already been processed, like a battery that end of life, there's less energy that's required, less waste that's produced. So therefore, that's actually beneficial towards reaching that net zero.
Mm. And give me a sense of the size, though, of what it's going to take to actually create proper battery recycling industries.
So I think, like I said, a lot's happening very fast. You've seen a rapid uptake globally of batteries, especially in electric vehicles. There was a report just recently saying that by 2030, we're going to have 11 million metric tons of lithium-ion batteries for EVs that are out being used. On average, at the moment, you're looking at around 10-year lifespan for an EV battery. So in 10 years' time, that's a lot of end-of-life batteries that are going to have to be managed and processed in some way. So
Mm.
the recycling part of that, it's still working out what are the best ways to recycle materials from batteries. So there's a couple of methods. There's a pyrometallurgy method, there's a hydrometallurgy method, and there's also a new method called direct recycling. So at the moment, there's still a lot of flux, but people are looking at how to improve those technologies as well to deal with that waste stream that's coming in the near future.
How effective are the current methods of battery recycling?
I think if you go back a couple of years, maybe 5 to 10 years, they're pretty standard methods. But what we're seeing now with the push for net zero, a real big drive around sustainability, circularity, also safety. There's a lot of talk, not only in the battery area, but also in other areas such as textiles, plastics, the electronics industry, about going circular and having green processes to do that as well.
But what does battery recycling actually involve? Which bits of it can we recycle and which bits can we not as yet recycle?
That's a good question. Currently, a lot of this is driven by the chemicals that are inside a battery. So if you take a typical battery, it's an electrochemical cell. So it has a cathode, it has an anode, it has a separator that separates the two electrodes, and then you have an electrolyte that allows the electrons and the ions to move back and forth between the electrochemical cell. And then you put all that inside a casing, which is typically metal and plastics. So at the moment, a lot of the interest is really about recycling the critical metals. So in a lithium-ion battery, some of the best batteries are using lithium, manganese, cobalt, and nickel. So those are actually critical metals. So getting those metals back out is really important to making new batteries. But likewise, that only makes up about roughly 20% of the battery. So there's still about 80% of that battery that needs to be recycled. And in the last couple of years, we've actually seen industry starting to think about how do we recover those valuable processed materials and put them into either new batteries or repurpose them in other applications.
Let's just look at the 20% for the critical minerals. Just flesh out for me how we actually extract them with the current technology.
Yeah, so one method is called pyrometallurgy. So for example, that's a difference between lithium-ion batteries I need to explain first and say lead-acid batteries is the chemistry. It's very different. There's lots
Mm.
of chemistries that can be used for lithium-ion batteries depending on end-use application, whereas the battery that you have in your typical car is generally a lead-acid battery. So it's easy to collect, recover and recycle the lead-acid battery. It's around 98+% efficient globally now. But with the different chemistries that you have in a lithium-ion battery, if you can't separate that chemistry, it becomes very problematic downstream when it comes to pulling out the various metals. So one method which doesn't really have an issue with that is called pyrometallurgy. So here you just take the full battery. You don't have to worry about taking it apart. You put it into a massive furnace. You burn it at very high temperatures, and you end up forming a metal alloy slag. And then you then do some chemical processing to pull out the various metals. Problem with that method, it's very energy intensive. There's lots of gases and emissions that come out from burning all sorts of things like plastics and chemicals. And then you still have to do some sort of back-end processing. The other method I mentioned was hydrometallurgy. So that's more classical with what we do in the mining domain. So here you're taking a mixture, and by doing certain chemical treatments, you can pull out specific metals when you want to. And then another method which is coming out, which is called direct recycling, which is very different to the two methods I just mentioned. Here, you don't want to go back to your base chemicals. So, say for lithium, you might go back to lithium hydroxide. In the direct recycling, what you do is you actually separate your cathode and your anode, and you try to rejuvenate those electrodes. So you don't actually change the structure of the cathode and anode. And by doing that, there's a huge cost saving by not having to go back to those basic chemicals.
And would it be less polluting than the other methods?
That's correct. So some of the stats that are coming out in the field talk about why we want to move away from always having to be reliant on using raw materials. So, for example, some of the information that's out there, you can get lithium from salt lakes. So, in South America, there are a lot of brine salt lakes which have lithium in them. So, to get 1 ton of battery grade lithium, you need to use at least 750 tons of brine. If you go back to minerals from ores, you're looking at around 250 tons of ore. But if you look at a spent lithium-ion battery, you only need to use about 28 tons. So if you think about the energy and all the waste that gets produced along that way, it's really sensible to be thinking about pulling the value out of those spent batteries at end of life.
Yeah, a much more sensible way to go, it strikes me. Now, what about that 80%, the non-critical minerals part of the battery? How are we going on actually getting that recycled?
I think that's sort of been an area that's slowly starting to grow. I think that's really been driven by circularity and sustainability. So if you think about what's happening, if you have 80% of materials that are not being used, you don't really want them going to waste. So people are now starting to look at the anode, for example. That's generally a carbonous material. How can we pull that out? And then you've got other chemicals such as the electrolyte, the separator. They're all organic polymer-based materials. So how do you pull out everything, and how do you get that up to the battery grade so you can reuse it in the next generation battery? Or if you can't, how do you use it in another application? Which is also another option as well. So it just doesn't go into landfill at the end of the day.
Yeah. Do we know what the size of battery waste is going to be in the future?
I think what I mentioned before, 2030, it's just EVs alone, that's 11 million metric tons. So it really comes down to being able to supply the materials. That's one of the challenges at the moment. Everyone's sort of strapped for the materials that go into batteries. But I think we're seeing it being used in a variety of areas from electric vehicles and plus battery energy storage systems. So I think there's going to be continual growth, and that will create a challenge at the front end, but also an opportunity at the back end to recycle.
And what are the main challenges to the commercialisation of recycling batteries here in Australia?
I think the study that we did comparing the US with Australia was really insightful. Like we think about, and we see this in other areas with recycling. We think about the amount of materials we generate and how can we, be environmentally friendly and collect that waste and recycle it. But what's been really useful by comparing what's happening in the US and Australia is really there's several factors. One of them is population size. So for all intents purposes, the US and Australia have roughly the same land area, but you're looking at a population difference where the US has around 330 million people, whereas Australia only has 27 million people at the moment. So the amount of material that you're likely to get to develop a sustainable recycling industry in Australia isn't there at the moment. And part of that's due to our uptake. I mean, if you look at the US, they've decided to really go down electrification of vehicles, and that's to move away from combustion engines. So that's really driving that uptake of electric vehicles. That means you have more vehicles coming on the market, and at some point you'll have a bigger quantity of materials reaching end of life. In Australia, that's not the case. Australia is still learning how to transition across to electric vehicles. One of the common things we hear is a comment about range anxiety. So what we're seeing in Australia is as we move towards electrification, we're seeing more hybrid vehicles. So the slower we transition, the less materials we'll have coming at end of life, and that will sort of make it harder to do a recycling industry in Australia.
That's really interesting. So because we have been so slow, we may be impeded in the next stage in that recycling industry. Where does that leave us, though?
I think, look, at the moment, a lot of our lithium-ion battery waste, what you do with it is at end of life, you can't ship that battery overseas because it still has a residual charge. So what people typically do in Australia is they'll get it, they'll crush it, shred it, and they'll turn it into this thing called black mass. So that has all the chemicals that's inside the battery, and they ship that overseas. And what's been interesting to see when I first started working in the space around 2017 is that black mass was pretty well seen as just a waste material. Some companies overseas would pay for that to take it off our hands, so to speak. But within the last 6 years, you've now seen that black mass become a very hot commodity. There are countries that do not have the mineral wealth that Australia has. And so for them to get into that battery supply chain, they're actually out paying anywhere from between $5,000 to $10,000 for high quality black mass.
Right.
So there is a growing demand for that. And another driver behind that is most countries or regions in Europe, they're looking at by 2040, looking at 70% recycled materials going into batteries. And the US is gradually also increasing its targets as well about how much recycled materials go into next generation batteries. So there's a pull for that industry to really grow globally. I think Australia has a role, maybe not in Australia, but maybe the Asia Pacific region. Not every country will have a recycling capacity or capability. So having regions that can support an ecosystem would be really valuable.
So you think that because we have been slow in the EV uptake, and because of the size of our population, and I suppose where it's situated within the continent, that we are unlikely to have an industry that totally supports our recycling?
I think to get the quantities of end-of-life batteries that you need, that's not going to happen within Australia alone, just because of how fast we're taking up the technology. But other neighbouring countries in the Asia Pacific are, so they will have the same issue about what to do with those end-of-life batteries when it becomes a waste issue. And not, like I said, not every country will be able to recycle. They may be able to convert it to a black mass, but that's where Australia could possibly come in, take that black mass and then convert it back into the battery chemicals that we need to make new batteries.
So we'll be taking the black mass from the South Pacific and Southeast Asia regions, you reckon?
Oh, possibly. I think it's a good opportunity. If you're looking at how the energy market is transitioning as well, they want to have renewable energy instead of conventional energy. Process a lot of the materials that we're making now, not only in recycling but also in our ore and mining capacity. So Australia has a lot of opportunities and one of the biggest uptakers of renewable energy. So that could be a way to do more green processes in Australia, which would make us I think, more economically sustainable to do that sort of chemistry here.
So where is our current waste going to be recycled at the moment?
It's still, the black mass is just getting shipped overseas. So we do have, there's a few companies looking to try and recycle, and it's sort of that catch-22. If they don't have enough battery waste of the right chemistry to recycle, it just means they're delaying recycling it. So that's that sort of to and froing. If they had sufficient amounts, it'd be a viable process to be sustainable.
Just clarify for me, what's the energy footprint and cost of recycling compared to, say, raw material processing?
Look, that number's a bit hard to really pin down because a lot of the processes at the back end are still changing. But some of the statistics we've found is if you take a recycled battery or use a end-of-life battery and take out the materials, you can save up to 40% costs currently with the current technologies. Your energy use can be reduced by at least around 80%. And one of the other important things is your water use is also reduced dramatically around 70%. And plus there's reduced emissions as well. So because you've already taken out some of the impurities that you don't need when you're making battery chemicals. So there's a huge benefit. So I think that will improve as the technology improves over time as well. It's just something that's really starting to ramp up in recent years.
What What about second life applications for EV batteries, using them as home batteries when they're no longer good for the cars? What are the advantages and disadvantages of those sorts of applications rather than recycling?
Yeah, look, that's a good question. That came up in that workshop that I attended in the US in 2018. So you've got all this inherent value in a battery that reaches end of life from electric vehicles. So generally they have about 80% state of health. So they do have some more use. Some of the things that have come out is understanding how the battery gets used. So a car that you drive and a car that I drive may be driven in different ways, and therefore the battery health could be different after that end of life. So you have to do something to work out the health of the battery, and you want to match that health between other batteries as well. So um, doing all that is labor and time intensive, and also ownership as well. Who owns that battery at end of life when it goes into the next technology? Something else that's changing very fast is battery chemistry. So the chemistry I have today, if I look forward in 10 years, could be quite different. So we could have smaller, more efficient, more powerful batteries. So do I really want to have a second life battery used in that application, or do I want to pull the materials back out and make that next generation battery? So it's still up in the air. There are some places globally trying to look at second life. Likewise, there are other companies that are interested in taking that battery waste and pulling out the valuable materials and making new batteries. So that's still a changing area.
Yeah. In your recent paper, you talked about a battery passport. Why do you think they are so important?
So there's a number of reasons. Part of that's related to I mentioned the chemistries of batteries are very different from lithium-ion batteries. There's a whole range of chemistries that are used in the cathode and the anode. And what we're seeing in recycling, if you bring all that together, it really becomes very cost inhibitive, and also you consume a lot of chemicals to try to pull them back out. So one way they've spoken about this is to have a battery passport. So this could go from the beginning where the materials are actually coming from. So this is just relating to the environmental, social, and governance framework that's being adopted as well, to making sure that you're using materials that are sustainable and circular. But likewise, it's a way to track where those materials have come from and also the chemistry. So at end of life, you might imagine, if you look at that passport, it'll tell you it's this type of chemistry, therefore you can start sorting. You currently can't do that easily, and that really impacts the efficiency of recycling at the moment.
Right. So that's going to be absolutely vital. I mean, who's going to be responsible for bringing in something like a battery passport? It's going to take every government, isn't it?
I think a lot of policy and regulations are being driven by Europe at the moment, and I think a lot of other countries will fall in line. If we're looking at chemicals being shipped globally and batteries being shipped globally, we will end up just following a lot of those policies that are being introduced, because we'll have to work with those supply chains.
Uh, you've talked about the leading role of Europe. What about the United States? I mean, the United States has brought in its Inflation Reduction Act, which is going to have a massive impact globally, including on their recycling industry, their battery recycling industry. What's the likely impact it's going to have on us?
I think that's a good question. I think that's really driven. We see this in a lot of countries. Countries are looking at developing sovereign capability, and this has really been born to light after COVID, where a lot of countries have been impacted by supply chains. One of the things in the paper we looked at is also the mineral wealth that both countries have. So Australia has all the critical metals and also the base metals that's needed to make lithium-ion batteries. The US doesn't, so it's going to have a supply shortage. So that's where it'll be looking at engaging with countries um, which they do trade with, such as Australia, to try and get some of those critical metals into their manufacturing of next generation lithium-ion batteries. But at the same time, they're looking at being sustainable. So using batteries that come from recycled, or chemicals that come from recycled batteries, is a big driver in the US, part of the Inflation Reduction Act. So what it's really doing is supercharging the whole country to focus to all these key challenges, and then trying to find solutions for them in the time frame where they see these really becoming a problem for waste streams.
But is there a risk that Australia will just get stuck in the same paradigm that we have been stuck in with fossil fuels, that we dig it up and ship it out and we don't value add?
Oh, look, that's a great question. I think I'm a keen supporter. We talked about developing a battery supply chain in Australia, and I think part of where we are as Australia, as the size of the country, is we do the front end really good. And I really think if we think about recycling the back end, and we can close that loop and bring that together, and then start not shipping ores overseas, but starting to process them domestically, and then ship the battery chemicals overseas, we'll actually start to close that gap from both ends to hopefully build a battery supply chain in Australia. So it's a huge opportunity for Australia.
As we've been discussing, there's this increasing focus on creating circular economies that are sustainable. Do we have to actually design batteries quite differently from what we've been designing them now to ensure that they are designed with a view to recycling?
Look, that's a great question. We talked to a lot of the people, both companies that have made batteries for cars. In some cases, they've been overly engineered just because of safety reasons. So they haven't really thought about what happens to batteries at end of life. So, in the classical term, would be cradle to grave. But now what we're hearing is cradle to cradle. So I think for lithium-ion batteries, that sort of commercial technology has really set sail. People have invested lots of money to fabricate batteries with that certain chemistry and architecture. Where the opportunity lies is in next generation batteries. As we move away from lithium-ion batteries, we need to be a bit more holistic when we think about the materials and the design of the battery. So how do we design it in such a way that the materials are easy to recycle, the battery is much easier to pull apart, and so that will save on costs, the economics, and also the environmental issues associated with repurposing or reusing batteries.
Are we likely to move away completely from lithium ion batteries, though?
I think I really do think, and I've seen this when I spent time in the US working on energy generation. So we spent time at a national lab in the US looking at how we could generate electricity. And the answer there is there's not one solution to how to generate it. And I think it's going to be the same with how we want to store it. It'll really come down to designing fit for purpose batteries or energy storage systems for where they're going to be used. So I think we're starting to see some of that now. Maybe another way to look at it is you look at cars. There's different types of cars. People like to have sports cars that are, fast, light. People like to have cars that get you from A to B. There are cars that carry large loads and cars that go off road. So I think we'll see batteries being designed for different end use applications, and that I think will go beyond lithium-ion batteries. And if that occurs, we'll start to see, I think, diversity of energy storage as well. So I already know there's some people looking at sodium-ion batteries. Sodium's more abundant, but to make a sodium-ion battery, you need a different cathode, an anode, and electrolyte. So there's always technical challenges that need to be solved. Likewise, in energy storage, large energy storage such as grid, there are some technologies that are starting to come to light now. Likewise, they also have some work to be done to move them from the lab scale to industrial scale.
But does that diversity just create further problems for the recycling industry? Because as you've been explaining, we need some consistency within the recycling product, I suppose, or the stuff that gets recycled.
I look at it the other way. If we know a certain type of battery chemistry is going to a certain domain, it's much easier to track. At the moment, battery chemistries are going to all sorts of domains, so it's an even harder way to track where those chemistries are going. So, for instance, you might see in the future, maybe lithium-ion batteries are not the way for long duration storage. There could be a new technology comes along.
Mm.
And if that's the case, and that demand on those critical metals won't be needed in that application. So it actually allows those materials to be used in other applications where it's definitely needed. So
Mm.
I think diversity will be a good thing. Likewise with how we generate electricity, there's no silver bullet to this. There's solar, tidal, geothermal, hydro. So there's going to be a mix depending as well on geography and location.
What do you think the Australian government needs to do to help create a strong recycling industry? And are there lessons that we can learn from what is happening overseas, particularly, I suppose, in Europe and the US?
Look, because I've spent time in the US, I quite like the approach where they have the Department of Energy making a lot of calls as to where where their long-term goals or challenges are at the country level. So that sort of helps drive academics, government national labs, and also industry on long-term projects. So somewhere between 7 to 10 years. So this is a grand challenge, and by doing that, it allows everyone to align to take on some of those challenges, but also security to know that if we invest time and effort, there's a good chance some of these technologies will make it to the marketplace. The other thing we've learnt as well, I think it's always nice not to reinvent the wheel. So the Department of Energy has spent a lot of time and effort pulling together policies. And so I think other countries near us as well, some of them are further down that journey than we are. So I think it's just good to look to see what they're doing. But we don't have to copy, but we can take a leaf out of their book and implement what's worth doing in the Australian context. And that could be different. We're seeing that as well between the US and Australia as well. We're going down electrification, but we're going down a slightly different route. The US are pushing very hard for electric vehicles. In Australia, we're actually taking a lot more battery energy storage systems online. And maybe one of the things that you raised before, what could government do? I think having better connectivity between what the states are doing. I know some of the states, from my discussions with the Australian Battery Research Initiative, some of the states are doing, in some cases, their own thing. So we just don't have the population density of the materials. So trying to consolidate that into something more national would be really good. But mostly, from what I understand, most of it's just getting converted to black mass just because the quantities are not there, and then that's currently getting shipped overseas.
Surely there must be things that the government can do to, put the parameters in place that will encourage an industry?
Yeah, I think, like I said, I think that's where, when I was in the US, the Department of Energy had these really big, grand challenges, I guess. They look at a sort of a 10-year window because they're realistic about the gaps and the technology problems that need to be overcome. So, and they sort of throw everything into that. Not everything's going to be successful. Some things will flourish and some things will die out. I just it's just fast fail sort of mentality to get to that target. I think we don't have a long-term vision, and I think that could be something that could be improved. Just because it brings a lot of security to even companies that want to go down that path. They know that this is where we're going. There's opportunities for even employment as well. We don't have certain trades in this country that we need, and as we transition to electrification, so education is really important. Future jobs are really important as well. So they're the kind of things I think stimulate people at the day-to-day to think that this is where it's going. There are opportunities for everyone, not just for the science and the manufacturing and so forth. So maybe something like that I think is worth considering.
Yeah, I mean, we are going down this track, and if we don't have that long-term vision, I would envisage that we're going to have problems.
Oh, look, that's a good question. And maybe the other thing I've noticed in the US, there's about 20 plus national labs, and they used to be very independent. And I think what the government's realised as well is that instead of having them work in similar areas but not talk to each other, they now have processes and fundings rounds where they're asked to collaborate together. So you're getting the maximum bang for buck out of all your capability.
Right.
And we could do something like that in Australia as well. So we've got different universities, we've got different industry partners, different parts of the supply chain trying to do things. But how do we do it in a much more effective way? Because then we'll get much better bang for buck instead of people not working together. It's a very fast moving area.
Do you think that there's enough effort now looking at this question?
Look, I think I can always say more would be better, but I think partnering as well has been really useful for us to understand what it is we should be focusing on. So I think there's more opportunities. I really do see this as a growth area. And I think the US have recognised that this is the future, electrification. So getting that security at a country level, being able to close loop we'll develop sovereign capability for the US, but that'd be the same for us as well. We want to have our own independence to make sure we can sustain energy for the future for the things that we need to do as a country. So I think it's a real opportunity to be involved.
Good opportunity, but lots of issues to sort out there, aren't there?
That's great.
Gavin Collis, thank you so much for joining the Switched On podcast today.
Oh, you're welcome. Thank you very much, Anne.
And Gavin Collis is a synthetic chemist working on batteries at the CSIRO in Melbourne. Well, that's a wrap for the Switched On podcast. I hope you can join me next time when I'll be chatting to someone else at the forefront of Australia's electrification journey. I'm Anne Delaney. See you then.